Think like Tesla.
Hello, wonderful person. Think like Tesla, Micah here. Today we're going to revisit an old project, and we're going to talk about printed circuit board design and some common mistakes that you might make if you're doing it for the first time. Program note here, starting with this very video, you'll notice some different audio and video quality. Let me know in the comments how this comes through. If you appreciate it, if it sounds better, let me know. And stick around to the very end for a special announcement. All right, quick recap since it's been a while. I scored these really cool 16-segment LED displays, and you can see here that they have a very fine pitch to them. So this wasn't something we could just put on a breadboard. Therefore, circuit design time. So each of these units has two characters in it. So there's one pin heading out to each of the LED segments, and they have a common anode. And each pin has a letter assigned to it. You'll see this on the schematics. So the only way to really make this display the way you want it to is to multiplex. We have to alternate back and forth between which characters we're displaying at any given moment in time. So there's several ways to do this. The way I chose was to use 64 bits worth of shift registers. So this would be enough space for 4 of those 16-bit characters, either even or odd, to display at one time. So start off with, say, odd. We'd feed the 64 bits into the shift register, latch it into place, and then light up those LEDs, and then repeat the whole process on the even side. Then alternate that back and forth quickly enough so that there was no visible flicker. And then this whole thing would be driven by an external CPU, like an Adafruit Feather. And the intent was all along to make this an open source hardware project, but it never really made sense to put the files out there when the thing wasn't actually working yet. Now that it is, that's all changed, so stay tuned for more on that. And with no further ado, let's get into the top 11 problems. Connectors. These DuPont connectors really sucked. So you can see on the screen here, this is how I had to bodge things out just to test it. I ended up putting a 2.0 millimeter connector on there. It's super glued down to the board. The wires are run out to the connection points, which are just kind of scattered around on that side of the board. In the updated version, this all goes out to a nice connector, put in place where it belongs, and with proper mounting. Likewise, on the front side, there were no IC sockets for these narrow pitch connectors, so I ended up using a double density pin headers. I cut them into pieces and I put them on the board, and it just never made good connection. It was flaky. I had to push down on the thing. LED segments would flicker on and off depending on how I held it. It was just a disaster. That said, I don't know what else I could have done differently. If you guys have suggestions, I'd love to hear about it in the comments. This version of the circuit board had a complete absence of test points, which kind of turned out to be a problem when things didn't just work on the first go. So it would have been really nice to have some places to stick probes and to look at things. And a little sneak peek here at the new backside. This is just a render. See the test points here? They're nice little rectangular spots to put your probe on, and they exactly fit a Keystone 5015 SMT connector if you want to solder something on. Maybe I'll talk about those more in a future video. Okay, now this doesn't count as a board error per se, more of a thinking error. I did not include any kind of a self-test mode in the software for this. I mean, this goes into the bigger concept of designing for testability, which is something you should have in mind at all points when designing your project. And along those lines, the final output in this 64-bit string of shift registers was left unconnected. Now, leaving an output, a digital output unconnected, that's totally fine. That can happen in your circuit, it won't cause any problems. But it would have been really nice to feed that bit back to the original CPU. Then I could do all kinds of interesting self-tests, make sure things were shifting through the system, make sure the data was flowing as I expected it to. While it's true I did have plenty of decoupling capacitors sprinkled all over the board, they were nice and neat, tied in with the power leads on these ICs, it would have been even nicer to have a larger capacitor, maybe towards the input side of things, just to make sure we had any electrical disruptions smoothed out better. Turning to the schematic diagram, now this didn't affect the board layout at all, but I had an embarrassing mistake. Somehow in the layout for the pins, I managed to mark a input pin as a ground. So it just bugged me, looks bad. Okay, this one was an outright design mistake. In the switching transistors that turn all the LEDs on or off, I used an NPN on the high side transistor. High side switch did not work. Well, it worked, but when you set it up that way, the transistor doesn't fully saturate, and it makes the LEDs have different levels of brightness and waste energy. Just use a PNP. Here's a weird one. There was one outright missing trace, just completely missing. I don't know where that came from. I don't think it was, I designed the board that way because my electrical rules check would have found the missing wire. I don't think it was a manufacturing defect necessarily. I think their tests would have detected something like this. So yeah, I'm perplexed. I don't know how this happened, but I had to bodge it and move on from there. The last couple ones here were just things that annoyed me. I made some mistakes on the silk screen. I didn't clean things up as much as I should have. So I had a 5-volt label at one point where it should have said 3.3 volts. And I also marked incorrect resistor values. That was actually kind of a last minute change, but still the board was wrong and it was annoying. So for the bonus round, let me put up the renders of the new layout here. You guys can have a look at these. Welcome any comments, any suggestions, further improvements I can make in this. One thing you'll notice is the whole board is somewhat bigger. There's really no reason to make it as tiny as the previous one was. The idea was that this was going to be used as a name badge. Name badges don't have to be these tiny little things. I was also able to make the spacing on the corner mounts there exactly match an Adafruit Feather, which is the CPU I was using to power this. So that's convenient if I want to bolt those things together. And also on the manufacturing side of things, the resistor networks I used here are tiny. Man, these things are tiny. They have 16 pins altogether. It's 8 resistors in parallel at about 0.5 millimeter pitch. This was probably one of the most challenging things I've ever had to hand solder in my life. And this is enough to make me really look at the PCB assembly services that they offer. Oh, I almost forgot to mention, the new board also uses a 4-layer design. That's also gotten very affordable and easy to do. Having a ground plane and a power plane inside the board just made all the other routing so much easier. I mean, look how much cleaner the backside of this thing is. It's just so much simpler. Totally recommend that also. So there you have it. I learned a lot from this project, which was my goal. You'll learn a lot too if you try it instead of just watching videos. So I strongly encourage you, get in there, build your circuits, design them. It's gotten so cheap these days that it's really worth it. So the natural question here is, now what? Where do I go from here? I think the obvious thing to do would be to send in this board and get these made, get them soldered up. I would probably do so without using the sockets. I will just put those LED units right into the board. And before I do that though, do you guys have any thoughts, any comments, any questions? Is there anything else I should look at or change or consider before I send these off to get made? Let me know. This episode is sponsored by... You don't have any sponsors. Okay, so my imaginary producer is telling me we don't have any sponsors, not even Patreon. But if you like Tesla-related content, you are welcome to join a new community that was getting started, full of a bunch of weirdos like you and me. You can keep up with a bunch of my creative projects, and I can't believe I need to say this, but it is free. There'll be no cover charge to get in now or ever. I haven't even seen any other channels do this at this point, so maybe you can get on something before all the cool kids are doing it. This is a small group, very elite. Come join me. Links are in the description. If you have any questions or comments, leave them in the comments, and stick around. There's a lot more coming, a lot more to talk about here, a lot of good stuff on the way. And if you like this, you want the YouTube algorithm to suggest similar things to this to you, hit that subscribe button and the little bell notification button, and that will give the all-knowing AI the information it needs to serve you. All right, see you guys soon.